In this video, we'll go over the rule of twos of the basal ganglia. The first rule says there are two stimulatory neurons, the ones coming from the cortex and to the cortex. The second rule says there are two inhibitory neurons in a row. And lastly, the two eyes are inhibitors. The globus pallidus internus and the indirect pathway will inhibit movement. So we'll start by drawing the cortex, the thalamus, and the subthalamic nucleus. Here we have the lentiform nucleus, which is formed from the globus pallidus internus, the globus pallidus externus, and lastly the butamine. We'll add to it the caudate to make the striatum as one structure for the sake of simplification, since they have similar function. So let's start with the direct pathway. As we said, from the cortex it will be stimulatory, and to the cortex also it will be stimulatory. Then we would have two inhibitory neurons in a row, the first one from the striatum to the globus pallidus internus, which is an inhibitor. So when you inhibit the inhibitor, it will be stimulation, or in mathematical terms, negative times negative is positive. And as you can see, this will result in enhancement of the movement. So the direct pathway goes with the movement. Let's move to the indirect pathway. The same rules apply. From the cortex and to the cortex, it will be stimulatory neurons. Then we would have two inhibitory neurons. But now, from the striatum to the globus pallidus externus, and from the globus pallidus externus to the subthalamic nucleus. Then, from the subthalamic nucleus, it will be stimulation to the globus pallidus internus. And as we said, the globus pallidus internus always inhibits movement. So since we are stimulating the inhibitor of movement, this will result in inhibition of the movement. And this is the function of the indirect pathway. Lastly, we have here the midbrain, and in which we have the substantia nigra, from which dopaminergic neurons will act on the striatum. In the direct pathway, they will act on D1 receptors, which are stimulatory. So once we stimulate the direct pathway, this will enhance the movement further. And in the indirect pathway, they act on D2 receptors, which are inhibitory receptors. And since we are inhibiting the inhibitory pathway, which is the indirect pathway, this will enhance the movement further. Now let's shift gears and talk about disorders. Degeneration of the substantia nigra is seen in Parkinson's disease, whereas damage to the subthalamic nucleus will result in contralateral hemiballismus. And lastly, degeneration of the GABAergic inhibitory neurons from the striatum, especially in the caudate, that act on the globus pallidus externus, is seen in Huntington disease.